right, so what we're gonna do is we're gonna take these trig functions, these graphs of sine, cosine, tangent, and what we're gonna do is we're gonna learn how to move them around in the coordinate plane. So there are four main types of transformations that we're gonna be able to do by the time we're done working with this. Okay, so I'm gonna write those out just to give you a heads up. They're all written on that handout that I gave you, but I'm gonna tell you just what they are really quickly here. There's something called phase shifting. So phase shifting basically just means moving a trig function left or right. That's one type of transformation that we can do. The second type is messing with the period, which means we can shorten it or we can lengthen it. And the period is defined as the distance that it takes to complete one full cycle. Whether it's like a cycle of the sine, or a cycle of the cosine, or cotangent, or secant, or whatever it is, the period is going to be how long does it take to complete that one full cycle. So we can phase shift, we can mess with the period, we can mess with the amplitude. Any physics people in here? What's amplitude defined as? Distance from basically how high and how low the wave is, right? So the distance from the top to the middle, or the bottom to the middle. It's not the two of them added together. Some people think the amplitude is like from the very highest point to the very lowest point, but we measure it in trig functions from the center line. So the center to the middle, center to the top, or to the bottom. So we can have phase shift, we can have period, we can have amplitude, which is up and down basically, and then we have vertical translations. Vertical translations mean actually physically moving the graph up or physically moving the graph down left or right. Sorry, left. Jeez. So here are four main types: phase shifting, period, amplitude, and vertical translations. The whole second box here is basically the handout that I gave you in class. Okay, so there is a handout that goes with this. So if you don't have it, I'll get it to you. I'll put it up on the web, but let me explain it to you. Basically, it goes over, I'm going to use black. It goes over a bunch of everything you possibly want to know. It takes all four of those pieces and puts it into an equation. So the handout says f of x is equal to plus or minus c, plus or minus a, times the sine of w times x plus or minus d. Now that is a lot of stuff, and I totally would agree that there's only what the heck is all of this stuff mean, all right? Well, notice here that there are four things, right? We can have the c variable, we could have the a variable, we could have the w variable, and we could have the plus or minus d variable. Each one of those four variables, yes?
It says on the handout plus a.
Put a plus or a minus. Doesn't matter. Okay. Each of those four things represents one of the types of transformations that we could do. And I'm going to go through those briefly with you right now. So right out in front here, this plus or minus c part, this is a constant. This part is known as that's your vertical translation. So that will be up. You'll move the entire graph up if c is greater than 0, or it'll be down, physically down, if c is less than 0. So that part just moves the graph up or down. The a part, this part right here, that's our amplitude part. That's our amplitude part. So if it says, if we want to graph the 5 times the sine of x, then the amplitude is going to be a value of 5. So it's going to go up 5 and down 5. Now, if your amplitude, if this value here, if a is negative, that implies that you have a reflection over the x-axis. Okay? So that part is your amplitude. That corresponds to amplitude. The w, this is your period. And the way you find a period for sine and for cosine is you take 2 pi and you divide it by whatever number that is, and that will give you the period, and we're going to mess with that one. That one's the hardest one to do. And then lastly, this part is left and right. That is your phase shifting. So I'll put PS for phase shifting. It goes, if your D is greater than 0, then that means you go left. So it's the opposite direction you think it would be. If your d is less than 0, that means you go right by however much d is. Okay? So this is basically the handout right here. The handout's a little bit prettier, but it also gives you an order in which you do things on the left-hand side. See how it says do this in the following order on the left-hand side? What's the first thing that you're supposed to do? The phase shift. So you want to do this first. What's the second thing you do? Period. Do that. Then the third thing. And then the, oh, Jesus. Third thing. Yeah, there you go. So the third thing and then the fourth thing. And that's all on the handout, right? Basically, you do the hardest thing to the easiest thing when you're trying to graph these, okay? All right, so we have phase shift, period, amplitude, vertical translation. And we're going to do these one at a time here. I'm going to do two sine curves for you and then two cosine curves for you. So we're going to graph together f of x equals 2 minus the sine of x. And this is where the colors come into play. 2 minus the sine of x. So I have two things that I need to do to my sine curve. Can anyone tell me, based on what's in front of them, which two things am I going to have to do? Am I going to have to do a period, a phase shift, a vertical translation, or an amplitude? Can you pick out the two things that you're going to have to do? All right, Caitlin, give me one of them. What do you think? A vertical translation by how many units? Yes, up or down? Yes, this says to me that I'm going to have a vertical translation 2 units up. Good. There is another thing that is going on. Michael, what do you see, buddy? Yes, and you know that because this is a negative in front of your sign, we have a reflection over the x-axis. Okay? And which one are we going to do first? The reflection, and then what? Then the vertical translation. That is basically it. Okay? So when you draw these out, we're going to go from 0 to 2 pi unless it says do something else. Okay? Unless it says do something else, then you do whatever it asks you to do. But the default is going to be from 0 to 2 pi. Okay, so here's how it works out. If we're not changing the period, then we keep everything the same as we did before. So pi over 2, pi, 3 pi over 2, and then 2 pi. 1, 2, 3, -1, -2, -3. All right, since I'm graphing a sine curve, the first thing that I'm going to do is put on there is the sine of x. And that's going to be my reference point, and I'm going to use 5 points to define that. I'm going to have 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, 2 pi 0. So there in black, or whatever color you're using, that's your sine curve. All right, next we're going to do the amplitude, which is a reflection. So I'm going to pick a different color. That's why you have the colors out there. And I'm going to do y equals negative sine of x. So it's going to be in blue. Okay, if I reflect each of those 5 points over the x-axis, 2 of them change places and 3 of them stay there. So the first one stays where it is. Pi over 2 becomes down to -1. Pi stays where it is. 3 pi over 2 goes up to +1, and 2 pi stays where it is. So now my blue graph is the graph that I'm working with. Yeah, it is, huh? And then finally, I'm going to have 2 minus the sine of x, which means that I'm going to push all 5 of those blue dots physically up 2 units. So 1, 2, dot there, 1, 2, dot there, 1, 2, dot there, 1, 2. That's why graph paper is super important of this, okay? So my end graph is the red graph that's been shifted up 2 units. All right, so we're going to graph sine of x minus pi over 4. There's only one thing that I'm doing to this graph. What is being done to this graph? There's only one thing. Can you figure out? Is it a period? Is it an amplitude? Is it a phase shift? Or is it a vertical translation? Which one is it? It's a phase shift. Yeah, it's exactly right. Thank you. Right. I have a phase shift because I'm working on something inside the parentheses here. And which direction am I going to go, you guys? I'm going to go to the right. How many units? Pi over 4, or a 45-degree increment, right? You guys got it. Okay, so again, I got pi over 2. I got 3 pi over 2, and I got 2 pi. And since I'm dealing with a sine curve, I'm going to go up to 1 and down to negative 1. And I'm going to graph y equals sine of x first. So I have this basic 5-point graph here. So there's my sine curve. All right? The only thing that I have to do is shift these, phase shift them pi over 4 units to the right. But the question is, where the heck is pi over 4 units to the right? It's right between 0 and pi over 2. So this represents pi over 4. So that means that this is 2 pi over 4. And this has to be 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which is the same thing as 3 pi over 2, 7 pi over 4, 8 pi over 4 is 2 pi, and then 9 pi over 4. So I've just rescaled my my x-axis in terms of pi over 4, so I know where to put all those dots, right? So I'm going to move each dot pi over 4 units to the right. So you have this cool looking thing that looks like that. That's pretty terrible in the middle, but that's what it looks like. So my red graph is the sine of x minus pi over 4. So do you see why the colors help? They tell you which way it's going, and you really only have to mess with 5 dots every time that you do it, okay? So I'm not asking you to graph a whole lot, just asking you to graph 1 period and 5 dots, okay? All right, I'm going to switch to the cosine curve now and do a period one, because I only have time for one more. So we're going to graph y equals the cosine of 2x. And this will be our last one because we're running out of time. Pi over 2 pi, 3 pi over 2, and then 2 pi. And then I'll call that 1, and I'll call that negative 1. Okay, first we're going to graph cosine of x. So we're going to start with here. All right, there's our cosine curve. All right, now generally, the cosine has a period of 2 pi because it takes 2 pi radians to get from start to finish of one full cycle of the cosine curve. But we have a 2 that's been put in place. So what do we do with that 2? What does the 2 mean? How come it's there? What do we do with it, right? So what we're going to do is we're going to take the regular distance of the cosine curve and divide it by the number that's been put into our equation. So 2 pi over 2, if I simplify the fraction 2 pi over 2, I get a period of pi. This is my new period. Now, is that greater than or less than 2 pi? It's less than. So now all of a sudden, I need to fit an entire cosine curve in a length of pi. So you can kind of think of this as like an accordion, and I'm going to squish my cosine curve down into a start and finish in a distance of pi, instead of a distance of 2 pi. Does that make sense? That's what I'm doing? Okay, so this is actually a lot easier than it seems, okay? I know the cosine curve has to start here, and I know it has to end at pi, and the end value has to be up at 1. Because over here at 2 pi, it ended up here at 1, right? I know halfway between, it's going to be its lowest point, which is down here at negative 1. So really all I have to do is figure out what's going on here and what's going on there. Well, those points are intersecting, so what I really have is this right here. So therefore, I've squished my period all the way down to a distance of pi. So if I kept going with this, right, then this would be an intercept here, this would be a low point, that would be an intercept there, and that would be, and end up at 2 pi. So as you can see, right, what I've got going on here is I've got I've got two cosine curves in a distance of 2 pi, and that's what the 2 means. Does that make sense? I've got two cosine curves in a distance of 2 pi, which means I have to shrink the period down to pi in order to make that work.